Hello everyone, welcome to the session. So this side Priya Bhatia, and in this video we will be discussing about the bias and variance. So until so far I believe that you already have understood the complete concept behind the linear regression algorithm. We have discussed in a very detail about the mathematical intuition, about the implementation, right? Each and everything in a great detail we have already been discussed. Now I think it's the right time we should go in a lot more detail with respect to the problems that we usually face whenever we try to train any algorithm. So this is not per se linear regression I am talking about today. With respect to any algorithm which we will discuss in the future also, this problem of overfitting and underfitting or bias and variance will come into picture. So today in this video I will try to discuss this problem in a great detail, right? It's a kind of an error that we will discuss now, and I hope that you will be able to get a very unique insight of this particular part as well. So without wasting any time, let's get started. So now, whenever we are talking about the concept of bias and variance in machine learning, we need to understand the very first thing that both of them is an error. So it's an error which is composed of, I can say, a bias plus a variance. So in a way, whenever you are training your model, what you want is that machine learning model is having a very low bias and very low variance in order to get a very low error, because at any point of time our actual ideal scenario of any model training or learning is that we should have a minimum error, right? Now whenever we're talking about a bias, it clearly indicates that you are talking in terms of a training error, okay? In terms of a training error, which is, let's say if you're saying that I will be having a very high bias, it means that you want to say that a training error is very, very high in a given model. So basically, I'll try to give you one simple example. Let's say I will be having one model, and in that you have been given, let's say the height of a person as an input. So height is something which is X is given to you, which is an input. Corresponding to given height, let's say what we want to do is we want to do a prediction of weight, which is Y. Okay? So height is available, and as per the height, what we are looking for is the weight. Okay? Now, what we have done is we have been provided the data points in our data set that we have, and we try to train our model, and model looks like this best fit line. And this is the data points, let's say, that we have. Okay? This is the data points that we have. Assume. Now, this is something where you can say that, okay, my model is having a maximum error. Means when I'm trying to train my model contains a very huge amount of error as per the training itself. So here the equation of line will become, I hope everyone knows, y is equals to mx plus c. And maybe this might not be the correct way to find a best fit line with respect to this particular data set that we have, right? So in this case, what is happening is that what I will say, your model is underfitted. Another term is underfitting. So what is the simple meaning of underfitting? That your model is not able to understand even the simpler data. Your model is not able to understand even the simpler data. And that's the reason that your model is giving a very high training error. Very high training error. At the time of training itself, the error is very high. And obviously, if your training error is very high, at that point of time, your testing error will also be very high. It makes sense, right? If in your training data itself, you're not getting a very good output, very low error, very good accuracy, how can you expect that at testing it will work perfectly fine? So it means that whenever we are talking about underfitting, it simply means that we will be having a very high bias, right? Very high bias means we will be having a very high training error. Means we will be having a very high training error. This is the literal meaning of when we say that, we will be having a very high bias in our model. Okay? It's an error. Which error? Training error we are talking about. Now let's come ahead and move towards the variance concept. Now let's say I tried to, plot this again with another way of fitting that line. Let's say the problem statement will remain the same. We will be having a height as the input value, as the x-axis, and we will be having a weight as the expected output, which is the value of y. Now let's say I have trained my model on this particular kind of a equation, kind of a parabola, right? And this is the kind of, I would say, data points which is provided to me. Now in this case, if you will be able to observe, we will be having a very low error. I hope everyone knows that whenever we are talking about an error, for example, here also I was talking about the error. What does that meaning? Error meaning that we will be having a difference between the actual value and the predicted value. And this difference will be very, very low. This is what we want. In this case, the error or the residual is very high, right? That's why we said that it's a high bias frame of model which is underfitted. Okay? Now, when I'm saying about this error, can you see that the difference between the actual and the predicted, let's say this is the actual point, this is the predicted point, it's very, very small, right? As comparable to the above case. So this is something which you can say might be an ideal scenario, right? This might be an ideal scenario, which actually at every point of time we want to achieve. And this composed of some different equation, because it's not a straight line. It is something which you can say is y is equals to m1x plus m2 x square plus c, kind of a quadratic equation we have. But let's say there can be another possibility which can exist here. Let's say the model is trained like this, where you will be having a data points here, 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 and here. So what is happening? In this case, if you will be able to observe, the error which I was talking about, which is the difference between the actual and the predicted line, is approximately equals to 0. The difference between the value of y and y cap is approximately equals to 0. Can you clearly observe this, right? This is the situation where your training error is approximately equals to 0. Okay? This is where what is happening. Let's say you will be able to form this kind of a model, right? What will happen is this is following this kind of a curve. Y is equals to m1x x1 plus m2 x1 square plus m3 x1 cube, let's say until m4 x1 to the power 4 plus c. This kind of equation. What was the above equation? It was in the quadratic form. Here, if you want, you can also take only single x rather than taking x1, just like the way we have done in the above part. Let me not take different variables here so that you guys will not get confused. So the thing will remain same. Problem statement will remain same. What is x and what is y? Here we will be having height as the input parameter, which is x, and the prediction value is weight. Again, things will remain the same, right? But the equation of line got changed again. In this case, if you will ask from me, or if you will be carefully observe this particular plot, what you can see in this case, you can see that in this scenario, you will be having a almost minimum error. So usually you can say that, Priya, if we will be having in third case the minimum error, so this should be ideal case. Why you are saying that the second case is ideal one? Try to understand now. See, when I'm saying training error is approximately equals to 0, at the time when the testing data will come into picture, what do you think? Will this model will be able to behave the best? Not at all. Because let's say this is a very, very complicated curve, right? Which we have got here so that the error will be minimum. So in this case, what will happen? At the time of testing, if you will compute the error, it went to very, very high. It went to very, very high. Why? Because there is a reason behind this. Because your model learns the noisy data points also. Which actually it should not learn. It should not learn, so that it will be able to give us the best results. What is our target? Our actual target, or our actual scenario, ideal scenario will be, actual target will be to not reduce only the testing error, but also to get as minimum as training plus testing error. So what we want is, we want as low as training error, plus we want as low as testing error also. That is where you can say that you will be having a minimum error in your model and your model behaves the best, right? So this kind of thing where we are saying that we will be having a very low bias, because training error is very, very low. It means that you are having a very low bias, but at the time of testing, you are getting a very huge change in the, values. Error is very, very high. Means you will be having a very high variance. This is the meaning of variance. The variation between the training and testing error is very, very huge in this case. So what is happening here? That we will be having a very high bias. very low bias, because training error is very low and the variance is very high. What is the meaning of variance? I am again repeating. The difference between the error values of testing versus the training part, right? So this is the situation which we called as a situation of overfitting of any model. Overfitting of any model. Okay? And again, we don't want this, right? So high variance means that we will be having a huge variation between training and testing error, which is happening here, right? Training and testing error. And the major issue behind this is, just now I have discussed, that my model is learning the even complex data points, noisy data points. That's the major huge issue. So why is this an ideal scenario? Because in this case, you will observe that you will be having a low bias, means you will be having a very low training error, plus you will be having a very low variance, means the difference between your values of training and testing error is approximately same. So this is what we want. We want that the value of the training error and the value of the testing error is approximately equivalent to each other. That is the main target, that is the main deal. So now the question is that how we can avoid, first of all, underfitting to be happen. Okay? That's the very first instance. So until so far we have discussed what is underfitting, what's the ideal scenario, what's overfitting. Now let's talk about that how can we avoid this underfitting scenario to happen. The one simple thing which we can do here is that we can simply add more data points. We can simply add more data points in order to avoid the problem of underfitting. Because in underfitting, what is happening is my model is not able to learn properly. So let's say if we will add more data points, my model will be in a situation to learn more, to get the data points more, right? Similarly, when we're talking about overfitting, what can be the way to, reduce this particular thing? Maybe we need to focus more on what are the noisy points we have, right? Maybe we can try to target the outliers, which is the extreme values that we have in our data. We'll try to reduce them, right? So that our model will not learn all these noise data points that we have. Apart from this, there is something which is very interesting that we have in overfitting, something called as regularization techniques, which I will discuss in the upcoming session, regularization techniques. So basically, we have few techniques. In deep learning also, we have something called as a dropout. In machine learning, we have some regularization techniques, which is basically helps us to avoid this problem of overfitting where we will be having a low bias and the high variance kind of a issue, right? So this is the overall idea behind the concept of bias versus variance, behind the concept of overfitting versus underfitting, behind the concept of what is the ideal case scenario. So I hope that now you get a complete end-to-end idea about the bias versus variance, right? Overfitting versus underfitting. And now in future, if at any point of time when you are doing any project, you find this problem, now you know that how you can overcome them, right? So with this, let's end today's video. I hope that you like the today's session as well. And I'll see you all very soon in the upcoming videos.